Right now, as you are listening to this story, you probably imagine space as a huge empty place where planets and stars simply float around. It feels calm, silent, and perfectly flat. But the truth about space is far stranger than most people realize. Space is not empty, and it is not flat. In fact, space itself can bend, stretch, and curve in ways that shape the entire universe. This incredible idea completely changed how we understand gravity, planets, stars, and even time itself. And it all began with one man who dared to see the universe differently: Albert Einstein. Before Einstein, scientists believed that gravity was a simple, invisible force. According to the famous scientist Isaac Newton, every object in the universe pulls on every other object with gravity. The bigger the object, the stronger its pull. This explanation worked very well for hundreds of years. It explained why apples fall from trees and why the moon orbits the Earth. But Newton never explained how this invisible pulling force actually worked across empty space. It was a mystery that no one could fully understand. Then in 1915, Albert Einstein introduced a completely new way of thinking about gravity. Instead of gravity being an invisible force pulling objects together, Einstein proposed something much more fascinating. He said that massive objects actually bend the fabric of space itself. To imagine this, picture a large trampoline, stretched tight. If you place a small marble on it, the surface barely changes. But if you place a heavy bowling ball in the middle, the trampoline sinks and curves downward. Now when a marble rolls across the surface, it does not move in a straight line anymore. It curves toward the bowling ball because the surface itself has been bent. This is very similar to how gravity works in the universe. Planets, stars, and galaxies are like heavy bowling balls sitting on the fabric of space. Their mass bends and curves the space around them. When smaller objects move nearby, they follow the curves in space created by those massive objects. The Earth bends space around it, and the Moon follows that curved path. That is why the Moon orbits our planet instead of flying away into space. The Sun bends space even more strongly because it is much larger and heavier than Earth. All the planets in our solar system move along curved paths in the space shaped by the Sun's gravity. But Einstein's discovery went even deeper. He realized that space and time are not separate things. Instead, they are connected together as one structure called space-time. Imagine space and time woven together like threads in a giant cosmic fabric. When something massive, like a star or a planet, sits in that fabric, it bends not only space, but also time itself. This means time does not flow at the same speed everywhere in the universe. Near a massive object where gravity is strong, time actually moves more slowly. This might sound like science fiction, but scientists have tested it many times with extremely accurate clocks. Even astronauts in orbit experience time slightly differently from people on Earth. Because they are farther from Earth's gravity, time moves just a tiny bit faster for them. This effect is so real that the GPS satellites used for navigation must constantly correct for Einstein's equations. Without those corrections, your phone's location could be wrong by several kilometers every single day. Einstein's theory sounded strange when it was first introduced, but scientists soon began testing it. In 1919, during a total solar eclipse, astronomers made an incredible observation. They noticed that light from distant stars bent slightly as it passed near the sun. According to Einstein's theory, the sun's massive gravity was bending the space around it, and the light was following that curved path. When the measurements matched Einstein's predictions perfectly, the scientific world was stunned. It was the first direct evidence that space itself could bend. As scientists explored Einstein's theory further, they discovered even more extreme objects in the universe. One of the most mysterious is the black hole. A black hole forms when a massive star collapses under its own gravity. The mass becomes so dense that it bends space and time dramatically. Near a black hole, space curves so steeply that nothing can escape its gravity, not even light. Time also slows down enormously near a black hole, creating some of the most extreme environments in the entire universe. Einstein's theory also predicted something called gravitational waves. These are ripples in the fabric of space-time caused by violent cosmic events, such as two black holes colliding. For many decades, scientists believed these waves existed but had no way to detect them. Then, in 2015, a powerful observatory called LIGO finally detected gravitational waves for the first time. The signal came from two black holes that collided more than 1 billion light-years away. The collision sent tiny ripples through space itself, and when those ripples reached Earth, they slightly stretched and squeezed the space around us. Even though the change was smaller than the width of an atom, our instruments were able to measure it. Today, Einstein's idea that space can bend is one of the most important discoveries in science. It helps scientists understand the movement of galaxies, the behavior of black holes, and the expansion of the universe itself. Modern telescopes and space missions continue to test Einstein's predictions, and so far, his theory has passed every experiment with incredible accuracy. Perhaps the most fascinating discovery is that the universe itself is expanding. Galaxies are slowly moving away from each other because the fabric of space is stretching over time. This means the universe is not static or unchanging. It is constantly evolving, growing, and transforming on the largest scales imaginable. All of this began with a simple but powerful idea. Space is not just empty darkness. It is a dynamic structure that can bend, stretch, ripple, and shape the motion of everything inside it. Planets follow curved paths because space itself is curved. Light bends because the fabric of the universe bends. And time flows differently depending on the gravity around us. So the next time you look up at the night sky, remember that the universe is far more mysterious than it appears. The stars are not simply floating in empty space. They are shaping the very fabric of reality around them. Invisible curves and ripples spread through the cosmos like waves across an endless ocean. And more than 100 years ago, one brilliant mind helped humanity discover this hidden truth: that space itself can bend.